Okay, everybody, I have two numbers here. They're in standard form, the way we're used to seeing numbers, and we want to write them, convert them into scientific notation. So the first number I have here is 7 billion. And obviously we can see it has 9 zeros as placeholders. So in most textbooks, we don't want to write that number out with all those placeholders. So we're going to write it in scientific notation. So step one is to locate where is the decimal point right now in 7 billion. Well, it's at the end. Okay? Our job is to move that decimal point so we can create a number bigger than 1, less than 10. So if you look, the only place to put that decimal point, so I make a number between 1 and 10, would be to put it right there. And that would give me 7.0. Now, I don't need to write the zeros because that's the whole point of scientific notation, is not to write the digit zeros. So we would just write 7 decimal point, or we can just write that as 7. Okay? Because we know any whole number, if we don't write the decimal point, it's understood to be there. Then we write times 10, because our whole number system is based on powers of 10. And then we count. We count how many positions does it take us to move this decimal point back to where it started. So our decimal point started here at the end. So we will count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would take us 9 positions to move that decimal point back to where it began. And because we're going to the right, our exponent is positive. 7 times 10 to the 9th is a number written in scientific notation. If you want to check yourself, if you took 10 and you multiplied it out 9 times, you would get a billion. And a billion times 7 would be 7 billion. All right, let's try one more. I have this small value of this decimal that has a lot of zeros in it. If I'm reading this, this is tenths, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions. So this is read 12 10 millions. It's a very small value. I want to write this in scientific notation. First thing, locate your decimal point. Well, it's here. I can see it. We want to move this decimal point to create a number bigger than 1, less than 10. So the only place I could put that decimal point would be right here between the digit 1 and 2. That would give me 1.2, 1 and 2 tenths. So I will write that decimal number, 1 and 2 tenths, times 10, because our place number system is all based on powers of 10. Now, to get our exponent, we're going to have to count. How many positions do I have to move that decimal point to get it back to where it started? So I placed it here, and I need to get it back here. So first thing I want you to notice is I'm going to be moving to the left. So if I move to the left, that means my exponent's going to be negative. And then I count. 1, 2, 3, 4, 5, 6 positions. So 12 10 millionths as a decimal number is written in scientific notation as 1 and 2 tenths times 10 to the negative 6th power. And that's all there is to it to write a number in scientific notation. In our next video, we'll go backwards. See you then.